Wonderful. I have two equations there, which means I can graph two different lines. This one will be yellow. This one will be blue. The yellow one, if I'm going to graph it, needs to have a table of values. Now, for some strange reason, that expression messes people up. Which is input, X or Y? Great. So who chooses what numbers to put in here? We do. Where do I put the numbers? In the X or the Y column? The X, because it's input. I'm going to input -2, 0, 2. So I'm on both sides of the origin, yes?
Yeah.
When X is -2, Y equals X. What's Y? -2. When X is 0, what's Y? When X is 2, what's Y? Easy peasy lemon squeezy, right? Then X, Y. We're going to do the blue one. Same digits. -2, 0, 2. When X is -2, what's Y? No. Positive 2. When X is 0, when X is 2, -2. Now we go over and we graph it. First thing we find is -2, -2. Where's that?
Right.
-2, -2, right there. 0, 0, and 2, 2. So that must mean graph B is the yellow line. -2, +2, 0, 0, 2, -2. That means that graph A is the blue line. Okay? Yes, it is extraordinarily easy. The problem with this is the concept that this teaches you, for some reason, is beyond you guys. How long will this line go for? Infinite. Okay? I'm going to give you guys a point that is somewhere on this screen. I want you to tell me if that point will work in either of these equations. Everybody ready?
Yes.
2, 1.
No. Yes.
See? People already don't get the concept.
I get it. Yes.
Is the point 2, 1 on either of those lines?
No.
No. How do you know that?
Because we can see the chart.
Where is 2? No.
There's no points 2, 1 on the chart.
Okay, let's try this. 5, 9.
No.
Why?
It's not on the chart.
Well, of course it's not on the chart. Chart only has 3 points on it.
The graph.
Okay. 7, -7.
No.
Yes, of course it is. Why?
Oh, yeah.
Because this line will continue,
Oh.
and 7, -7 will be on.
I get it.
I know.
So what is the concept I'm trying to get across to you right now? If the numbers exist on the line, then they work in the equation. If the numbers work in the equation, the numbers are on the line. Does everybody get that? It's not complicated, is it? And yet, here are two equations. There is one line.
That's a lot of work.
Yeah. Which of these two equations is that line?
2, -2. Oh, Y equals X.
It's this one?
No, it's the other.
It's this one.
You just.
I know he did. I'm giving him a chance to recant. Prove it.
You started at -2, so Y was -2. Then you went up to X and you added 2.
Y was never -2. I only have X values.
But you.
There's an X. X is 0. There's an X. There's an X. Why can I put 0 there?
0. Because you make the
Because the input, I've decided that I'm going to test the point where X is 0. What is 0 plus 2? 2. Right? That gives me a point, doesn't it? What are the coordinates of the point that this row gives me? 0, 2. What is this one? X is now
1, 3.
1, 3. So what's the point?
1, 3.
1, 3. And this one?
4, 2, 4.
2, 4. What's this one? 0 minus 2. What's this one?
Negative,
So what's the point?
negative, 0, negative.
0, negative 2. What's this one?
1 minus 2.
1 minus 2, which is?
Negative
So what's the point?
1, negative 1.
1, negative 1. And what's this one?
2 minus 2.
2 minus 2, which is? So what's the point?
0,
Now, I take all these points and I check with my line. 0, 2. 0, 2. Is that point on the line?
Yes. But no, it's not. But yes, it is.
I'll take a minute for you to sort it out.
Oh, this is the line. This is the line.
the line that.
The line that's graphed, Aiden.
That line.
Oh. No, it's not.
No. So if 0, 2 is not on the graph, will 1, 3 be on the graph?
No.
No. Will 2, 4?
No.
No. Which means this cannot be the graph of that, or the equation of that line, can it? But let's check. 0, negative 2. Yup. 1, negative 1. Yup. 2, 0. Yup. So since all of these, 0, negative 2, 1, negative 1, and 2, 0, are on the graph, then this is that line's equation. Every line you draw on a graph has an equation. How do you find the equation? We've already done that. You list the points, you check the change, and then you write the equation. Puneet,
Yes.
we're going to move you up to this desk now. Then move out in the hall. I thought you might.
May I ask why?
It was move you or Riley. I chose to move you. I'll move Riley next.
What have I done wrong?
You ready? Pack your bags lightly, because you'll be moving too. Identifying a graph given its equation. This is the opposite. Now we have the equation, but we have two lines. Right? So we have to decide which is which. How are you going to do this?
I can't see the board.
Times are tough all over. Guess you should turn around the side. Okay. You don't write anything down anyway. What difference does it make?
I
So,
in my head.
great. It's working real well for you. So, I have two lines here. What makes up these lines? Not quite. How do I know where I can draw the line?
You have points.
I have points from the line, right? Every point is what? What makes up a point? No. What makes up a point on a graph? What do I have to have before I'm allowed to put a dot on the graph? Coordinates. Those coordinates have what? X's and Y's, correct? So, I have line A, which is made up of X's and Y's, yeah? And I have line B, which is also made up of X's and Y's, yes? What are 3 points? You don't even need 3 points. What are 2 points from line A? You choose the points. Doesn't matter which two. You choose them. Don't say them out loud, just write them down. I'm going to choose -3 and -2 and 1 and 2. Cool? Excellent. Now choose 2 points from B. Again, you don't need to say them out loud. You just choose them. Everybody cool? So now everybody has 4 points, don't they? They have one X and Y, a second X and Y, a third X and Y, and a fourth X and Y. Where else in this question do you see an X and a Y? In the equation, Y equals X minus 1. You now have how many things to check on that equation? 8. But it's really 4 because they go as a pair, don't they? So here's an X, here is a Y. Where can I put this X and Y? I'll ask Perry, but he's tired, so we'll let him rest. Where do I put that X and Y?
-3, 2, -3, and
I can put -3 here. I'll do it in red because I was using red up top. I can put -3 there, -1, and what would I put in for Y? -2. Let's check. What is -3 minus 1? -4. And this side is -2. Does -2 equal -4? Of course not. So if this point is not on the line, is this point going to be on the line? No. So line A, this guy, cannot be line A. Which means he has to be line B, doesn't he? Are we allowed to say something in math like that? No, we have to prove it. How do we prove it? We take the equation, y equals x minus 1, and now what do we sub in?
we put -2 for the X.
One of the points from the other line. Does it matter which point you use? Of course not. Somebody give me one of your points that isn't one of my two. All you need to do is look at the page where I asked you to write this down. This is where I prove that nobody wrote it down. 2, that's only half a point. I need
I know, I don't know if
2 and 1.
2 and 1, great. So you went 2 and 1. That's a point that works. So Dylan used 2 and 1. What's that 2? That's an X. What's that 1? That's a Y. Where can I put them to check it? Into the equation. What goes in for Y? 1. What goes in for X? 2. What is 2 minus 1? 1. This side is 1. Does 1 equal 1? Yes. So this equation is line B. Got it? If the line's coordinates work in the equation, then that equation belongs to that line. If the coordinates show up, coordinates that work in the equation show up on the line, then those coordinates belong on the line. Got it? The key is X and Y, X and Y. What if we're doing a real life situation, not math class, where it's X and Y and X and Y? What would you use? What would be a better way to describe this? IV and DV. Because you're not always going to be using X's and Y's, are you? Right? Like when we measure the speed of a vehicle, do we use X's and Y's? What do we use? Kilometers and hours. Or miles and hours. Or as you get further into physics, meters and seconds. You need a distance and a time, don't you? Is that X and Y? No, it's IV and DV. One of them will be on the x-axis. Which one, usually? The IV is always, and in that example I just gave, it was time. Right? Cool? Okay. Prove it. Please look at how yucky all these words are. Please look at that. Look at how hideous it is. But then read it. Here's an equation, yeah? That equation has a left side and a right side. And then it becomes real easy, doesn't it? Right? Let's see if you can handle it. For A equals 0, 1. What is that 0, an X or a Y?
X.
It's an X. What is the 1? A Y. Then it even tells you what to do with it. So here's the equation, Y equals 2X minus 1. What goes in for Y? 1. What goes in for X? 0. So now, the equation that we're dealing with is really 1 equals 2 times 0 plus 1, correct? Right? Okay. What is the left side of that equation? The 1 or the 2, 0 plus 1? The 1, that's the left side. The left side of the equation is 1. Right? Okay. The right side of the equation is 2 times 0 plus 1. 2 times 0 is 0 plus 1 is 1. Cool? Great. Now we're going to check a second point, 1 and 3. Because is 1 point enough to check? No, because I could draw a line that goes through right there. Does that still have 0 and 1? But is it the same line as this? No, so I gotta check at least 2 points. This is when your teacher comes into play, who said you only need 2 points. Right? The reason I say when I was talking about 3 points, you were just getting a little confused. To draw the line, you only need 2 points because you could connect them. We use 3 because of this. What if my third one was over here? Can I connect those two? Does it make a nice straight line? But then what happened here? I zigzagged over there. So it didn't make a straight line. If you have 3 in a row, then you know you have a straight line. Because you can always line up 2 things, right? You and I are lined up. Is Aiden in the line? No. Okay? But if Aiden was over here, we could line it up. Always line up 3 things. All right, so let's check with B. What is this? What is this? So substitute X equals what? 1. And Y equals? So then I do the same thing. The left side of the equation is a Y. What do I write there? 3, because the left side is 3. The right side is 2 times what? 1 plus 1. What's 2 times 1? Plus 1? 3. Does 1 equal 1? Yes. So this point is definitely on the line. I should have ticked it in red. Right? Does 3 equal 3? Yes. So this point is definitely on the line. Once I have 2 points on the line, I know the rest of the line will work. Okay? Because I'm not drawing it. It's already drawn for me. So if these 2 work, that proves my changes are the same. Right? Gouda? Great. Let's see if you can really do it. I have 2 graphs, 2 equations. Right? So let's see if you can do it. Here's my first equation. There are my inputs. Go. Fill in your table of values. What are the 3 points that this will give you? I'll wait a moment while those of you that are writing write and those of you that are getting it into your heads get it into your heads. What number goes here? Negative 1, because I've said right here that x is negative 1. What is 1 minus minus 1? 2. What goes here? 0. What's 1 minus 0? 1. What goes here? What's 1 minus 1? 0. So this equation has what 3 points?
Negative 1.
Negative 1, 2, 0, 1, and 1, 0. Yes? Which of these graphs has those points? Graph A. Negative 1, 2, 0, 1, and 1, 0. So this equation matches graph A. Right? Which means this equation must match graph B, correct?
Yeah.
Are we allowed to say that in math class?
No.
No, we have to prove it. So, what do we got? Y equals, what goes in for x? Negative 1 minus 1. What's that?
2.
Negative 2. 0 minus 1. What's that? Negative 1. 1 minus 1. What's that? 0. So what are the 3 points that I got there?
Negative 1.
Negative 1, negative 2. 0, negative 1. And 1, 0. And we can see that those points are on graph B. Negative 1, negative 2, right there. 0, negative 1, right there. And 1, 0, right there. Does everybody see how it works? Now in grade 9, you will notice that we are always using whole numbers and perfect corners, yes? Does that exist in real life? No. Does this point exist on the graph? What do you think that point is? Positive a half, negative a half. Right? And does it work? The x was positive 1/2 minus 1 is negative a half, so it works. Got it? Okay. Which of these two lines is that graph? So, I have given you the 4 points. What if I didn't give you the 4 points? Where would you get your x's and y's to check this? From the graph. Could you choose any points on the graph? Yes. Why do I choose there, 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 and there? No. What is special about those 4 points? Look at what's common between all of them. None of you can see anything common between these 4 points. They all have zeros in them. Because if I got zeros in them, that's going to eliminate one of the variables, isn't it? Makes it easier to check. If you can check, if you can, use one of these guys that's what we call an intercept. Right? So, this side is the negative 3x or y? X and y. There's the equation. So y gets what? 0. X gets what? Negative 3. Negative 3 minus 3 is what?
Negative 6.
Negative 6. Does the left side equal the right side?
Yes. No.
0 equals negative...
No.
No, the left side doesn't equal the right side. So what does that mean? That means this point can't possibly be in that equation, which means this graph can't possibly be that equation. So do I need to even check point D? Do I need to even check it? No. Nice dab. Okay? I don't need to check it. because it's not there. Why then am I forcing you to check 2 points over here?
They might be on the line.
Because you have to make sure. Because I can draw an infinite amount of lines through that point. And 0, -3 is going to be on all of them, isn't it? But only certain points will be on this line. Cool? So, let's check E. Left side.
0.
No. -3, because it's the Y value. The right side. 0 -3, which is -3. Does -3 equal -3? It does. So I know that E is okay. Right? But I also know that I could draw a million, trillion, gazillion lines through there. And as long as they all went through 0, -3, they'd all be right, wouldn't they? But do I care about that infinity of lines? No, I only care about this line. So I got to choose another point from this line. Got it? Now we've already done 3, 0, right? I want you to choose a different point there, and instead of 3, 0, use a different point. What point could we use on this line? Somebody give me one. 2, -1, right? So we're going to use 2 and -1. So the left side is the Y side. Y equals what? -1, just like it says right here. -1 is our Y value, yeah? Okay, now the right side, what goes in for X? 2 -3 is? -1. Does -1 equal -1? Yes. So this point is on the line, making it okay. So graph B has that equation. And that equation will make graph B. Got it? Good. You have 27 minutes to work on page 188, and you are going to do three and 4. You are going to do 6 and 8. And you are going to do 11 and 13. And that will take us to our next break. After that break, we will finish this unit. We will lock in that. You will do your review tomorrow. You will start with a quiz, then you will review. We do not test on Fridays. You will be testing on linear relations on Monday, which means we will be starting Unit 6 tomorrow. Okay? Paneet, get out. Get out. Go sit on that bench. I will come and talk to you in a minute. Everybody else, there is your work to do.
Drink the water.
Yes.
They don't, because they grab it. That's their fault. But it is. So I'm going to warn you for the last 2 weeks. There is already this move over here of the tree side. You will think that I can do that. Yes, of course. But you will bear the fact that I already got the great idea. If you so if you need to fine. Where are you going? No, I don't think you do. I really don't. So I think
He's trying to pull off. He's just like this.
Yes, you do, right? You go to the gym?
you go to the gym.
You missed.
You ready, buddy?
Sure, Steve. What does that mean?
81. You should say 80.
What? Okay, next time. I don't know if you said 80. No. It's not funny. No. Like, don't try to be funny. It's not working.
No, I'm not upset. Like, if he's like,
No.
yeah.
You're next. You're next.
Me?
Yes, you. Okay?
Okay.
Got it?
Yeah.
His ice is this thin. Your ice is that thin. Your ice is that thin. Got it? Figure it out. Here you go. Get a textbook from behind you and try not to piss me off for 20 minutes. If you need help, ask for it. Excuse me.